trying to remember how to do these operations with rational expressions, think about, well, what do I do if they're just fractions? Okay, with multiplying and dividing fractions, I multiply the numerators, I multiply the denominators, and then I simplify. I cancel out what they have in common in the top and the bottom. With adding and subtracting, you gotta have a common denominator in order to be able to combine these things. So the first few examples we're going to do here do have common denominators. And then what do you do with fractions when they have a common denominator? What do you do when you're adding? What do you do to add fractions that have a common denominator? Anybody remember? It's been a long time, hasn't it? When they have the same denominator, so if I've got, let's say, 1/8 and 3/8. If I say, what is 1/8 plus 3/8? What do you do? You add the numerators. Do we do anything to the denominator? No, we do not do anything to the denominator. It's the same, it stays the same. Same thing with this, okay? If we have the same denominator, we add the numerators, we do not touch the denominator, okay? We do not touch the denominator. And then, just like with 1/8 and 3/8, when we add those, we get 4/8, which simplifies, right? 4/8 is 1/2. So we're going to do the same thing. We combine them, add the numerators, leave the denominators as they are, and then, we simplify if possible. I forgot to open my ink this morning. So with that first problem right there, they have the same denominator. They both have 4a squared in the denominator. So all we have to do is combine the numerators. So go ahead, my suggestion is just write your denominator down, okay? You got the same denominator, just write it down. Add the numerators together. 13a plus 5a is 18a. Be careful with that. The a doesn't change because we're adding. We're not multiplying here. We're adding. And then we need to simplify. So 18/4, those are both divisible by 2. So we've got 9/2. And a over a squared, we talked about that yesterday. We subtract the exponent. So 2 minus 1 is 1. It was bigger in the denominator, so the a goes in the denominator. So this is what we end up with. Now, let me show you real quick how to check this, okay? It's very, very easy to check this. Go to your y1. I'm going to keep showing you how to do this, okay? Put the numerator in parentheses, 13x over 4x squared. Make sure it's in parentheses, okay? Notice how my 13x is in parentheses, my 4x squared is in parentheses, plus parentheses 5x, close them, divided by parentheses 4x squared, close them. I said that the final answer was 9/2x, or 2a. I don't need parentheses around the 9 because it's just a single number, okay? I did need them over here because it was two terms, 13 and a, or not terms, but two things there, okay? Where am I going? The table, okay? We're going to the table. We're looking for all the y values to be the same. And they are. So that means those two expressions there are equivalent. That's what we wanted, okay? I'm going to keep showing y'all how to check these because this is what you need to do if you forget how to do it and you got multiple choice answer choices. Plug in the problem, plug in the answer choice, see if the y values match. Easy as that. All right, let's look at number 2. Okay, they both have a denominator of 16, so go ahead and just write that denominator of 16. Now, this one's a little bit different because it's a subtraction problem, so I'm going to take an extra step here. Because when we subtract, you have to apply that subtraction to everything in the rational expression that follows the minus sign. So that's minus 7x minus 2. Okay, minus 7x minus 2. So now I'm going to combine like terms. 9x minus 7x is 2x. 12 minus 2 is 10. I can simplify this one because what can I factor in the numerator? I can factor out a GCF of 2. And then I can simplify the 2/16 to leave me with 8 in the denominator. So I've got x plus 5 over 8. Again, I'm going to keep showing you. I know it takes time, but I'm going to keep showing you how to check these until y'all remember how to check these. Put 9x plus 12 in parentheses, divided by 16. I don't need parentheses around the 16 because it's a single number. Minus, parentheses, 7x plus 2, close the parentheses, divided by 16. Okay, my final answer, parentheses, x plus 5, divided by 8. Go to the table. Y values are the same. I'm good. Okay? Let's look at number 3. We have the same denominator, so we're good. Let's write it down. Now, this one's just adding, so I'm just going to go ahead and combine like terms. I'm not going to take that extra step that I did in number 2. So y squared in the numerator, that's the only one I've got. I've got an 8y plus a 2y, so that's plus 10y and plus 21. I'm just combining like terms. Now, I'm not finished. Okay, step 3 says simplify the remaining expression. That's what I did in the last problem. I'm going to do it here. I've got a factor. It's not factoring a GCF this time, though. What is it factoring? We've got a trinomial. So 2 sets of parentheses, y times y is y squared. What multiplies to give us 21 and adds to give us 10? 7 and 3, both positive. Positive 21, positive 10, so both positive numbers. How about that denominator? The difference of perfect squares, y plus 3 times y minus 3. Can I simplify anything? I got a y plus 3 in the top and in the bottom. So this simplifies to y plus 7 over y minus 3. Can I simplify anything else? We are not allowed to cancel those y's because the top one's y plus 7, the bottom one's y minus 3. They're not the same. They're not the same. So that's all we can do. Okay? Questions so far? Looking pretty easy, right? Not too bad. It's the simplifying part that we just got to watch out for. All right. So number 4, they have the same denominator. So go ahead and write it down. 2a minus 3. This is also a subtraction problem. So 1 minus 16a squared. We didn't have any like terms to combine, and I only had one term in the second one, so we're good there. Now, that's not in standard form. I don't like that, so let's fix it. Let's switch the order. Negative 16a squared plus 1. Let's go ahead and factor the denominator. What can we factor out of the denominator? A 3. We are left with 4a, just 4a. Am I right or am I wrong? That's all? That's all I need right there? 3 times 4a is 12a. Where'd my minus 3 go? I got to put a minus 1 there. Don't forget that. I did that on purpose to remind y'all. You got to put the minus 1. Multiply back out. 3 times 4a is 12a. 3 times negative 1, negative 3. All right. So, I don't like a negative leading coefficient in the numerator. So let's take out a negative. 16a squared minus 1 over 3 times 4a minus 1. That numerator, guess what? It's the difference of perfect squares. 4a plus 1, 4a minus 1. Now we can cancel those 4a minus 1s, and we are left with, I'd rather you just leave the negative in front of those parentheses right there. Negative parentheses 4a plus 1 over 3. So we did a lot of work there. Let's check this one. Okay, let's check and make sure that this one's good. All right, 1 over parentheses 2x minus 3 minus parentheses 16x squared, close parentheses, divided by parentheses 12x minus 3, close the parentheses. Our answer is negative parentheses 4x plus 1, close them, divided by 3. Look at the table. Y values all match up. So that original problem and our answer are equivalent. They are the same things right there. Okay? Let's do a few more. Well, let's do 2 more that have common denominators, and then we'll look at not common denominators. Okay, number 5. N squared plus 3n minus 7 minus n plus 1. Both of those are over n squared plus n minus 6. So let's go ahead and factor our denominator. Since we're writing it down, might as well go ahead and factor it. N plus 3 times n minus 2. N plus 3 times n minus 2. Let's look at the numerator. Let's write this one. Okay, since it's minus, we need to do minus n minus 1. Okay, minus n minus 1. So when we combine like terms, we've got n squared plus 2n minus 8. Can we factor the numerator? Somebody say yes. We can factor the numerator. Or I can factor the numerator. I don't know if you can. Y'all aren't making me feel very confident here. 4 and 2, positive 4, negative 2. Again, use the denominator to give you a hint. It doesn't always simplify, but a lot of times it does, so use the denominator. N plus 3, not going to work. 3 is not a factor of 8. N minus 2, that could work, because 2 is a factor of 8. And if it is, the other one's got to be n plus 4. So the n minus 2's cancel, so we are left with n plus 4 over n plus 3. Alrighty, let's look at number 6. It's got a little bit of a doozy of a denominator, doesn't it? 6k squared minus 5k plus 1, but they are the same. Let's go ahead and factor. Alright, let's go ahead and factor. In this case, I think it's going to be 6k times k that gives us 6k squared. The good thing is we only have one choice for what goes in second. 1 and 1, right? Because 1 times 1 is the only thing that's going to give us 1. It's a positive 1, so that means our signs are the same. The 5 is negative, so that means they're both negative. And guess what? I picked the wrong thing, because when we check it, we get negative 6k on the outside and negative 1k on the inside. That gives me negative 7k. I need negative 5k. Whoops. So that's okay. Easy fix. We just need to fix these numbers right here. What's our other choice? If it's not 6 and 1, 3 and 2. 3k and 2k. Let's check it. Outside, negative 3k. Inside, negative 2k. Negative 3k, negative 2k. Give me negative 5k. All right, easy fix. Okay, this is an addition problem. So let's add the numerators here. We've got 13k squared plus k squared, so that's 14k squared. And we've got negative 9k plus 2k, that's negative 7k. Here's an example of where it would have been easier if I had left my factoring the denominator to later, because I could have used the numerator to give me a hint, but it's all good. We needed to practice that anyways. What can we take out of the numerator? 7k. We are left with 7 times 2 is 14. K times k is k squared. And we need a minus 1. So the 2k minus 1's cancel. We are left with 7k over 3k minus 1. Easy enough, right? Well, that didn't work.